Hello everyone. Here we are going to solve one worksheet. Majority of the problems here are based on your past papers. The worksheet is regarding probability. Now let us discuss the first question. The diagram shows 11 cards. One of these cards is chosen at random. Write down the probability that the letter on the card is not A. Okay, so word not A is important. There are total 11 cards. Here I can see that two cards are labeled as A. So the card which are not labeled as A will be 9 in number, and therefore the possibility that the card is not A will be 9 divided by 11. Second question is, a card is chosen at random from these 11 cards and then replaced. A second card is then chosen at random. Find the probability that exactly one card has the letter N. Now here you have to pay attention on the word then replaced. Okay, you have to find the probability that exactly one card has letter N. Now it could possible that your first card will have letter N and the second card will be any other letter. I will consider that as X. Or you can have first letter as any other card and second letter as N. We have to find out the probability that exactly one card has letter N. Okay, now if I consider this first scenario, when my first pick has letter N, so here you can see that we have two cards with letter N, so it's a possibility will be 2 divided by 11. Now if you see the question, they said that the card is replaced. Now when I replace the card, the total number of card will remain same, 11. Now the second card I have to choose which is not N, so that I can do in 9 out of 11 ways. So it is 9 out of 11. Plus I have one more option that my first card is any other card not with letter N, so that will be 9 upon 11. Then because of replacement, the total number of card will remain same and the second card will be having letter N will be 2 divided by 11. So here your answer will be 9 times 2, 18. 18 divided by 121 plus 18 divided by 121. So which gives you 36 divided by 121. So here answer is 36 divided by 121. Now let us go to the next question. Second question is, the time t minute taken by each of 80 people to travel to work is recorded. The table shows the information about these times. Okay, so you can see time here. There are 3 people who require time between 0 to 5, 7 between 5 to 10, and so on. Now the question is, one of these 80 people is chosen at random. Find the probability that this person took longer than 10 minutes to travel to work. Give your answer as fraction in its simplest form. Find the probability that this person took longer than 10 minutes. Now let us see here. The number of people who are taking time longer than 10 minutes are this 18, 28 and 24. So let us add this 18, 28 and 24. The result is 70. Out of 80 people, 70 will take more than 10 minutes. So here possibility that the person took longer than 10 minutes will be 70 divided by 80. And in simple form it is 7 divided by 8. So here my answer will be 7 divided by 8. Now B part. 2 people are chosen at random from these taking 20 minutes or less to travel to the work. So 20 minute or less. Okay. So two people are chosen at random from these 20, those taking 20 minutes or less to travel to the work. Calculate the probability that one of these people took 5 minutes or less and the other took more than 5 minutes. Now, here it is a conditional probability. Already they mentioned that the two people we are choosing, they take less than 20 minutes. Now, less than 20 minutes, if I see, then there are 3 plus 7 plus 18 are people who take less than 20 minutes. So there are total 28 people. There are total 28 such people. Now the question is, calculate the probability that one of these people took 5 minutes or less and other took more than 5 minutes. So the first person, you have to condition whether you are taking less than 5 minutes. So I will say that less than 5. Okay. Calculate the probability that one of these people took 5 minutes or less. So it is less than 5. And second will be more than 5. Or you have first person who is taking more than 5 and second person will take less than 5. Okay. So calculate the probability that one of these people took 5 minutes or less and the other took more than 5 minutes. So two scenarios are there, whether the first person will take less than 5 minutes and second will take more than 5 minutes, or the first one will take more than 5 minutes and second will take less than 5 minutes. Now, if the first person is taking less than 5 minutes, so I have 3 such people. So here it will be 3 divided by, now total number of people 28 who take less than 20 minutes. So 3 upon 28, and other is taking more than 5 minutes. So out of 28, if 3 are taking less than 5 minutes, then 25 will take more than 5 minutes. So 25 upon 27, because one person if I choose, okay, then the remaining persons will be 27. Or, so here I will say plus, if the first person is taking more than 5 minutes, so it is 25 divided by 28, and other is taking less than 5 minutes, so it is 3 divided by 27. So therefore your result will be 3 divided by 28 times 25 divided by 27, and we multiply this with 2 because second option also have the same result. So our result will be 25 divided by 126. 25 divided by 126. Okay. So please pay attention on this second part of the question. Okay. Second part of the question. Okay. It is a conditional probability because they said that we are taking two people from those taking 20 minutes or less. Right? Okay. So now let us go to question number 3. Question number 3 is, in a class activity, all the 15 students wear hats. 7 students wear red hat, 6 students wear green hats, and 2 students wear white hats. One of these students is picked at random. Find the probability that this student wears a red hat. Now one student is picking at random. We have to find out that the student is wearing a red hat. So there are total 7 such students out of 15 students. So your result will be 7 divided by 15. So first part is very simple. Now second part, 2 of the 15 students are picked at random. Show that the probability that these 2 students wear hats of the same color. Now hats of the same color means either both are wearing a red hat, or both are wearing a green hat, or both are wearing a white hat. So you have both wearing red, or both wearing green, or both wearing white. Now when both wearing red, so first student wearing a red hat, its a possibility is going to be 7 divided by 15, and the second one will wear a red hat, its possibility will be 6 divided by 14. Or if both are wearing a green hat, then the first person wear a green hat, its possibility will be 6 divided by 15, and second wear a green hat, its possibility will be 5 divided by 14, plus third, now there are two white hats, so the first person wear a white hat, or the first student wear a white hat, its possibility is going to be 2 divided by 15, and second wear a white hat, its possibility is going to be 1 divided by 14. So 1 divided by 14. So here the result is, now denominator is same everywhere, so let us calculate the numerator. 7 times 6 plus 6 times 5 plus 2 times 1 is 2. So total is 74. So your numerator is 74 and your denominator is 15 times 14. So 15 times 14 is 210. So 74 divided by 210 will give me 37 divided by 105. 37 divided by 105 is my result. The C part is 3 of the 15 students are picked at random. Find the probability that at least 2 of these 3 students wear a red hat. Now 3 of the 15 students are picked at random. Find the probability that at least 2 of these 3 wear a red hat. So at least 2. So that means either 2 will wear a red hat or all the 3 will wear a red hat. So 2 are wearing a red hat, third I don't know, let us consider X. So the third one will wear a white hat or green hat, plus I can have first wearing a red hat, second wearing some other hat, and the third wearing red hat. Or I have first wearing some other hat, second wearing red hat, and third wearing red hat. Or I can have all the 3 students wear a red hat. So there are 7 red hats, so 7 divided by 15. Then it will be 6 divided by 14, and then it will be, now 7 out of 15 are wearing red hat, so remaining are 8 who wear green or white hat, so 8 divided by 13. Similar will be the result for this and for this. So what I will do, I will multiply this whole by 3 plus all wearing red hat, so it is 7 divided by 15 times 6 divided by 14 times 5 divided by 13. Okay, so here let us calculate the result. Your numerator is 7 times 6 times 8 times 3 plus 7 times 6 times 5. So your numerator is 1, 2, 1, 8, and your denominator is 15 times 14 times 13. Your denominator is 2730. Let us see whether it can be simplified further. 1218 divided by 2730. So yes, it can be simplified. The result is 29 divided by 65. So 29 divided by 65 is your result for part C. Okay. So this is your third question. Okay, now question number 4. The height H meter of 120 boys in an athletic club are recorded. The table shows information about the heights of the boys. Write down the model class. Now model class is the class where you have highest frequency. So here this is the highest frequency, so you will say that the model class is 1.5 and this is 1.6. So your H is greater than 1.5, less than or equal to 1.6. The second question is calculate an estimate for the mean height. Now to calculate the mean height, what we do here, we first find out the middle values. So middle value of 1.3 and 1.4 is 1.35. For 1.4, 1.5 is 1.45. Here it is 1.55. Then here it is 1.65, 1.75 and 1.85. Now I have to calculate the mean height, estimate for mean height. So it will be 7 times 1.35. What we will do, the formula is you have to take the addition of frequency and the value summation of f into x divided by summation of f. So this gives you, the first value is 1.35 times 7 or 7 times 1.35 plus second value is 1.45 times 18 or 18 times 1.45. So frequency is important. The values we know that it is 1.45, 1.55 and so on. So 30 into 1.55, that is plus 30 into 1.55 plus next frequency you have is 24. So plus 24 into 1.65 plus next frequency is 27 into 1.75, 27 into 1.75 plus 14 into 1.85 plus 14 into 1.85, and this whole divided by the total number of students are 120. So whole divided by 120. This is how you calculate the mean value. So 7 times 1.35, 7 into 1.35 plus 18 into 1.45 plus 30 into 1.55 plus 24 into 1.65 plus 27 into 1.75 plus 14 into 1.85. The result is 194.8. So it is 194.8 divided by 120. So this whole divided by 120. In simple form, we can write this as, in fraction we can write this as 487 divided by 300, or in decimal form we can say that this is 1.62. So here my answer is 1.62. B question, one boy is chosen at random from the club. Find the probability that this boy has a height greater than 1.8 meter. So greater than 1.8 meter. Now there are 14 such students. So here answer will be 14 divided by 120. So 14 divided by 120 is 14 divided by 120 will give me result as 7 divided by 60. So 7 divided by 60 is the answer. 3 boys are chosen at random from the club. Calculate the probability that one of the boy has height greater than 1.8 and the other 2 boys have height of 1.4 or less. So one boy has height greater than 1.8. So greater than 1.8, we have one which is greater than 1.8, and other 2 are less than, so 2 are there, so I will say that less than 1.4. This is symbolically I am showing. This means one is more than 1.8 and the other 2 are less than 1.4. So okay, or better, I represent more than 1.8 as say x represent greater than 1.8 and y represent less than 1.4. So I have to find, we have to find the probability that one boy has height greater than 1.8. That means x and 2 are y's like this, or you can have y, x, y, or you can have y, y, x. So in all these scenarios, I have one person with height greater than 1.8 and two persons have height less than 1.4. Now here greater than 1.8. Now let us see how many students have height more than 1.8. There are 14 such students. So here it is 14 divided by 120. Now once I choose one student, okay, the total number of student will be 119. Now the other student have height less than 1.4. So there are 7 such students. So it is 7 divided by 119, and the third will be 6 divided by 118. And in different orders, I have the same numbers. So I will multiply this whole by 3. And the result will be 14 divided by 120 into 7 divided by 119 into 6 divided by 118 multiplied by 3. So the result is 21 divided by 200,200,60. Okay, now the C part. Use the frequency table to complete the cumulative frequency table. Okay, so less than 1.4 is 7, less than 1.5 is 25, less than 1.6. So for 1.6, less than 1.6, 1.5 to 1.6, there are 30 such students. So I will add 30 to it. So 50, 25 plus 30 is 3 plus 2, 5. It is 55. Then less than 1.7 means from 1.6 to 1.7, there are 24 such students. So we will add 24. So 5 plus 2, 7, and 5 plus 4, 79. Then less than 1.8. So we will add 27. So when we add 27, 9 plus 7, 16. Okay, 2 plus 1, 3, 7 plus 3, 10, 106. And then when we add 24, it is going to be 14. It is going to be 120. So this is 120. This is 120. Now the question is, on this grid, on the grid, draw the cumulative frequency diagram to show this information. Now for less than 1.4, there are 7 such students. So here at 1.4, I will mark 7. So here I have 1, 2, 3, 4, 5 divisions. So each division represent 2. So 2, 4, 6, 7 will be somewhere in between. So here there could be 7. So this is 1 point. Better I will circle it. Then 25 at 1.5, it is 25. So 20 is here. 22, 24, 25 will be somewhere here. Okay, this is second point. Then 55 at 1.6, it is 55. So this is 40, 50, 55 will be here in between. So here 52, 54, 55 here in between. Yeah, this is 55. Then 79, 79. So this is 60, 70 and 79. So near about 80. So this is the point. And then 106 and 120. So 106 will be somewhere 100, and 246 will be somewhere here. And then for 1.9, it is 120. So maybe somewhere here. Okay. So now cumulative frequency. So I will join them with some smooth curve like this curve. So from here it is going like this and something like this. Okay, so this is my graph. On the grid, draw the cumulative frequency diagram. Now, using your diagram to find out the estimate for median height. So median height, so there are total 120. So at 60th position, nearby 60th position, I have median. So from here, the 60, I will draw a horizontal line, and from here I will draw a vertical line. So this vertical line will give me median. So this is 1.6 and 1.7. In between 1.6 and 1.7, 10 lines are there. So it is 1.61, 1.62. So 1.62 will be your median height, 1.62 meter, 1.62 meter. And then 40th percentile. Now 40th percentile. So here 40th percentile is 40 divided by 100 multiplied by total frequency is 120. So this 0 cancel, this 0 cancel. 12 for the 48. So now I will see that at 48, so from here I will draw a straight line, and then from here I will draw a vertical line, and this is 1.58. So 1.58 is your 40th percentile. 1.58. I hope you understand. Okay, when we are talking about percentile, that means out of 100. So out of 100 at 40th position, so then out of 120 it will be at 48th position. Okay, so that way we will find out. Median means at the center position. So if the total frequency is 120, at 60th position, whatever height I will get, I will consider that as the median height. Okay, so this is your question number 4. Question number 4, I think you give 1 more minute to revise what different answers you got, and then we proceed for question number 5. Okay, now let us move to question number 5. So here your question number 5 is, the diagram shows 2 sets of cards. Set A has card 1, 1, 2, 2, 2, and set B has card 0, 1, 1, 1, 2. Okay, now the question is, Jojo chooses 2 cards at random from set A without replacement. Find the probability that the 2 cards have the same number. Now Jojo chooses 2 cards at random from set A without replacement. So here word without replacement. Find the probability that the 2 cards have the same number. Now 2 cards can have number 1, 1. So when they have number 1, 1, it is 2 divided by total 5 cards. So 2 divided by 5 times 1 divided by 4. Or when I choose 2, so it is 3 divided by 5 times 2 divided by 4. Okay, you understand why I am writing 2 divided by 4? Because once I choose card 2, the total number of cards will remain 4, and out of 4 cards, number 2 card will remain 2. Okay, so if from set A I am drawing 2 cards, then the possibility of them to be same will be, this is 2 and this is 6, 6 plus 2, 8, 8 divided by 5 times 4, 20. So this is 2 divided by 5, 4 to the 8 and 4 5 are 20. So 2 divided by 5. Your answer will be 2 divided by 5. Jojo replaces the 2 cards. Jojo replaces the 2 cards. Kelly then chooses 1 card at random from the set A and 1 card at random from set B. Find the probability that the 2 cards have the same number. Now Jojo replaces the 2 cards, and Kelly then chooses 1 card at random from set A and 1 card from set B. Find the probability that the 2 cards have the same number. So if from set A Kelly choose card 1, so it is 2 divided by 5, and then From set B, if Kelly is choosing card 1, then it is 3 divided by 5. So 2 divided by 5 times 3 divided by 5. Or from set A, if Kelly is choosing number 2, so which are 3 numbers, so it is 3 divided by 5 times. Now from set B, if she is choosing 2, so it is 1 only, so it is 1 divided by 5. So the result is 3 times 2 is 6. 6 plus 3 divided by 5 times 5 is 25. So 6 plus 3 is 9. 9 divided by 25 is your result. Okay, now the C part is who is the most likely to choose 2 cards that have the same number. Show all your working. Who is most likely to choose the 2 cards that have the same number? Okay, so at the first position, I got my result as 2 divided by 5. Now this 2 divided by 5, if I convert in decimal, it is 5 4s are 20. So this is 0.4. This is 0.4. And in second case, it is 9 divided by 25. So 9 divided by 25 is 0.36. So this is 0.36. Now the question is, who is most likely to choose the 2 cards having the same number? So as 0.4 is more, as 0.4 is more than 0.36, we will say that the first person, who is Jojo. So Jojo, question is who is most likely to choose the 2 cards of the same name. So it's a Jojo. Okay, Jojo has more chance. His possibility of choosing the same card is 0.4, whereas the Kelly has the possibility of 0.36. Now sixth question is, a bag contains 3 green ball, 4 red ball and 1 blue ball only. Matt takes a ball from the bag at random. Some probabilities are marked on the probability scale. Write down the letter that shows the probability that Matt takes a red ball. Okay, so write down the letter that shows the probability that Matt takes a red ball. So there are total 4 red balls out of 4 plus 3, 7 plus 1, 8. So possibility of taking a red ball is 4 out of 8, that is 0.5. So the letter which represents 0.5 is letter E. Now Matt does not take a blue ball. So does not take a blue ball. So there is only one blue ball. So if he is not taking blue ball, that means he is taking any 7 balls. So 7 out of 8. So 7 out of 8 here, 1, 2, 3, 4, 5, 6, 7 and 8. So 7 out of 8, this letter H will represent 7 out of 8. Okay, now we are at question number 7. A bag contains 20 counters. One counter is taken from the bag at random. The arrow on the probability scale shows the probability that this counter is blue. Work out the number of blue counters. So this is 0.25. So number of blue counter will be 0.25 times, you have total 20 counters. So 0.25 times 20. 0.25 times 20 will give you your result as 5. So there are total 5 blue counters. Find the probability that the counter is not blue. Okay, find the probability that the counter is not blue. Now the probability that the counter is blue is 0.25. So 1 minus 0.25, that is 0.75, will be your answer that the counter is not blue. Now 8th question. So we will solve half of this worksheet, okay, in this class, and next half we will solve in the next class. Now Tanya plants some seeds, the probability that the seeds will produce flower is 0.8. When the seeds produce flower, the probability that the flowers are red is 0.6 and the probability that flowers are yellow is 0.3. Tanya has a seed that produces flowers. Find the probability that the flowers are not red and not yellow. Okay, so let me do this using a tree diagram method. Now Tanya plants some seed. The probability that seed will produce flower is 0.8. So producing flower, its a possibility is 0.8. So producing no flower, it is going to be 0.2. Now after producing flower, what is when the seeds produce flower, the probability that the flower are red is 0.6. So now possibility of getting a red color flower is 0.6 and probability that the flower is yellow, so yellow flower is 0.3. Now if you see 0.6, 0.3 to 0.9 means there is other color flower whose possibility is going to be 0.1. Now the question is, Tanya has the seed that produces a flower. Okay, so already know that Tanya has a seed that produces a flower. Find the probability that the flower are not red, not yellow. So probability that the flower is not red, not yellow is 0.1, right? Okay. Okay, so here we have that tree diagram. Okay, already we have done this. So this is 0.2. Here red color flower is 0.6. So this is 0.6. This is 0.3 and this is 0.1. Find the probability that the seed chosen at random produces a red flower. Find the probability that seed chosen at random produces a red flower. So that means you choose a seed, first of all, which gives you flower, whose possibility is 0.8, and then it is giving a red flower whose possibility is 0.6. So 8 times 6, 48, 0.48 is that possibility. Now Tanya chooses a seed at random. Find the probability that this seed does not produce a red flower and does not produce yellow flower. So does not produce the red flower and does not produce yellow flower. That means it could produce a flower of some other color, right? Okay, this is little confusing question. Think about it. Question number 8. Question number 8, third part. Okay, I will give you 1 minute to think and then we will try it. Okay, now let us try it. So the question is that Tanya chooses a seed at random. Find the probability that this seed does not produce a red flower and does not produce a yellow flower. So it could possible that it is not giving any flower. So it's a possibility is 0.2, or it is giving a flower but giving a flower of some other color. So it is 0.8 times 0.1. So it is 0.8 times 0.1. So this is 0.2 plus 0.08, which is 0.28. So here your result will be 0.28. Now this third part is two seeds are chosen at random. find the probability that one produces flower and one does not produces flower. Two of the seeds are chosen at random. Find the probability that one produces flower and one does not produces flower. So it is 0.8. If first is showing a flower, it is 0.8. Second is not showing flower, so it is 0.2. Or first is not giving any flower, it is 0.2. And the second is giving flower, it is 0.8. So your result will be 8 times 2 is 16, 0.16 plus 0.16. So your result will be 0.32. Okay, so 0.32. So total we have 18 pages. Now we are approximately at the 9th page. So we will stop here, and the rest of the problems we will continue in our next class. Okay. So till then, take care. Bye bye.